Good evening, one and all. I'm Shriyal Sethumadhavan, the feature editor of Indian Cement Review. I welcome you to the reduction of emissions in cement plants. As we all know, the major challenge for the cement industry has been GHG emissions that come from the burning of fossil fuels for the manufacturing of cement and also the MHG that we use, which is the fossil power. The industry has now been adopting to the use of alternate resource and are trying to reduce the energy intensity. And by using renewable energy and other innovations, efforts are being made to bring down the GHG emissions. But the other challenges for the cement industry also includes emission by dust, SOx and NOx, and the major challenge among these has been controlling dust emissions. Today's discussion will focus on the technologies and equipment to be used to control the dust. So has controlling emission levels within the cement plant been a constant challenge for you? What are the best available equipment and technologies to overcome this? How can you meet the requirement of continuous emission monitoring systems? And are there solutions to maximize productivity while keeping emissions under control? If these are your questions, then this webinar is for you. Presented by Evonik, the webinar is organized by First Construction Council and ASAP Info Global Group under the Indian Cement Review webinar series. I have all the panelists who've already joined me in, but before I go to the panelists to understand related challenges and popular solutions to controlling emissions, here is a brief introduction to the organizers. Yes. So introducing all of you to the Board of Governors of the First Construction Council, we have with us all the bigwigs from the industry. So we have Mr. Pradeep Singh on board from IDFC Projects, Architect Hafiz Contractor, Mr. D.K. Sen, Dr. Sandeep Singh, Mr. Subodh Dikshit, Mr. Sumit Banerjee, and Mr. Sanjay Seth. They all comprise our Board of Governors at First Construction Council. About Indian Cement Review, 30 years in running, distributed across 800 cities in India and overseas, and always committed to delivering the most authentic, trusted, up-to-date, and timely information about the cement business. Here it's a quick snapshot of all the publications from the House of ASAP Info Global Group. I'm sure many of you have already would have already been subscribers and are with us on these publications. And for those of you who haven't, you could still join us to get all the updates about everything that's happening in the industry. And yes, this is a big one that you certainly want to block your calendars for, the 11th Cement Expo Plus Online, scheduled for March 4th and 5th, concurrent events, which will include the 4th Indian Cement Review Awards 2021 and the 6th Indian Cement Conference 2021. If you need any further information to this, you could log on to www.cementexpo.in. I have the URL at the bottom of the screen. So you could log in there and you would get all the details to this event. Adding to all our offerings is the ASAP Digital Services. It's the subdivision of the same company, be it digital strategies, social media management, website creation, lead generation. You want to boost your business at a lowest agency pricing. We are your one-stop shop for that. Again, you could take a screenshot of the screen. I have given the contact details at the bottom. To benefit from our services, you just need to connect with us. And here's introducing you to the panelists who have joined me in today. Please welcome Dr. Stefano Santorsola, the Business Director of Evonik Fibres. Welcome. Dr. Georg Rathwallner, Environmental Consulting, Austria. Mr. K.N. Rao, Senior Advisor, Decarbonisation, Air Pollution Control, Environment, Energy and Sustainability. And Mr. Shekhar Joshi, President Technical, Ecomak Systems. I would like to welcome all our panelists. Thank you for joining me today on this session. Giving a perfect start to today's panel discussion, Dr. Santorsola and Dr. Rathwallner are going to make a presentation. While Dr. Santorsola will introduce us to the P84 fibers, Dr. Rathwallner will showcase some success stories of cement plants in India where P84 has helped meet emission requirements after premature failures. So with that, over to you, Dr. Santorsola, to take this forward.
You should be seeing my desktop, gentlemen. So Good afternoon, everybody, first of all, and welcome to the first beautiful webinar for India, giving your process filters a second life. I would like first to introduce beautiful fibers to all attendees by showing this nice image of natural gold yellow fibers. You may retain this information from this slide, that beautiful is the only hot gas filtration fiber presenting an irregular and multi-lobed cross-section. Beautiful staple fibers and multi-filament are available in the Evonik portfolio. A little bit of an history of this fiber. It was born in Austria back in 1984. It was immediately clear to us that beautiful most important characteristic was the multi-lobed cross-section. For more than 30 years, we at Evonik have delivered to the cement industry effective solutions for hot gas filtration thanks to the properties of beautiful fibers. Recently, we have increased the range of beautiful fibers qualities with the 1.3 detects, and last year we have launched P84HT, an optimized version of our fiber with unmatched thermal and mechanical properties. Here we are. This is a picture of showing where P84 has its home. We have the only one production site in the world which is located in Schördling and Lenzing. Actually, the spinning is located in Lenzing, where you can see the nearest site, and the after process and the offices are located in Schördling. This is in the lake area of Austria, very nice place near Salzburg. Now, a few words on the hot gas filtration value chain. Evonik fibers P84 staple and multi-filament are offered to our direct customers in the textile industry. They are able to process P84 into support scrim, needle felt, and finally, ready-made bags, which are delivered to your cement plants, as you can see from this animation. Since our position in the value chain does not allow us to serve you as vendors, we have developed a wide range of services, creating good value for your operations and allowing us to share our more than 30 years expertise with you. Our very well-equipped laboratory of chemical analysis and our skilled colleagues offer you the possibility to verify the composition and the construction of your filter media, your filter bags, their chemical and physical conditions even after several years of service, thanks to the use of specific analytical instruments. Furthermore, we are glad to assist you in recommending dedicated filter media for your most challenging applications. We are also able to assess the performance of existing filter bags and execute in situ gas measurements. Now, I would like to guide you through a brief description of the two major categories of filter media. Let's begin with the well-known woven glass with expanded PTFE membrane. This filter media is characterized by a PTFE membrane laminated onto a glass woven base. And as we see, there's a very thin line attached to the woven components, which is the blue, dark blue or light blue one. The membrane is actually the only part which does the filtration, but it is also fragile. It must be really protected during the storage, the handling, and the installation and the operation. Otherwise, abrasion can occur easily, and abrasion of a PTFE membrane is equal emission at stake. You see also that during operation and after post-cleaning, the PTFE membrane remains almost totally exposed to the gas flow. It doesn't retain, indeed, much dust. As you see from this picture, high-performance needle felts are a very different type of filter media instead, different from the previous. As you see, they are characterized by a three-dimensional structure where there is a supportive scrim between two non-woven fiber beds. In this case, P84 ensures a porous and permanent dust cake during operation. I would like to show what happens during the initial phases of a P84 bag pre-coating. You see that a certain amount of dust is coordinated with the fibers, and only after the process dust is arriving, we can allow jet cleaning, which removes the dust from the process, but does leave the pre-coating dust there, effectively protecting the filter media. High efficiency filtration, in fact, is unique characteristics of P84, together with this mechanical resistance compared to PTFE membrane mentioned before. And here is the nice first section of a P84 needle felt after operation. This one is even better. This image refers to a cross-section of a P84 needle felt, again, as I mentioned. The most important feature here is that formation of a lofty and permanent dust cake, which plays a determinant role in preventing fine dust penetration and the consequent increase of pressure drop across the filter. By achieving these two important targets, also the bag life is extended. You can really see how defined is the dust cake on the P84 filter media, and the rest of the felt is totally free from dust and free to breathe and allow good operation to your plant. So we have certain number of benefits offered by P84, which include low pressure drop, low emission, and long bag life. But how to explain this particular high performance of P84 compared to any other fiber in the market? To do that, we have to go back to the structure of this fiber to understand its behavior. In fact, back in the 80s, we observed low gas velocity areas in between the lobes of P84 fibers. You can see on the top left image, the cross-section of a P84 fiber presents blue areas. These are the areas in between the lobes where the gas velocity is almost zero. These areas naturally capture and retain the dust, thus creating a permanent dust cake which protects the rest of the felt from dust penetration and dP increase. Instead, standard fibers, pictured on the bottom left image, which have the round cross-section like any other fiber in the market, do not really display this feature. And there is a lot of turbulence around them, so the gas does not allow for any dust capture, and the felt is more exposed to the fine dust penetration during operation. Furthermore, the specific surface offered by P84 fibers, if you consider the weird shape of P84 fibers, even their circumference is increased compared to any other fiber of same dtex. So we have an increased specific surface of 65% if we talk about standard fibers, and that's a tremendous advantage when we talk about filtration. This translates into a very important advantage for you when evaluating bag-house expansions to cope with increased production capacity in case. And this happens quite often nowadays. So promising your process filter a second life, which is the title of this presentation, really means that. By adopting P84 media, you would virtually increase the filter surface of your bag-house without needing to add any compartment. That means zero capex. In fact, P84 fibers provide an extended specific surface at microscopic level, as shown in the previous images, which allows your bag-house to operate at higher air-to-cloth ratio up to 1.4 meters per minute without requiring additional compartments. This is quite something, I believe. This said, thank you so much for following till now. I would like to invite Georg to take over the second part of this presentation.
Thank you very much. I hope you can see the presentation now.
Yes, we can.
Perfect. So after the more theoretical introduction, I want to now show you a few practical examples how P84 could overcome problems in plants in kiln baghouses which occurred with woven glass. This first plant is in Andhra Pradesh, Suare Yarangundla. The plant, the baghouse was installed, and within 6 to 9 months, the woven glass bags started to fail, which resulted in higher emission. They have also tried other bag suppliers, but regardless which supplier, it was obviously related simply to the material quality, woven glass, which was not suitable for the conditions in this plant. The damage pattern looks quite similar in most cases with woven glass, since it's in most cases a mechanical damage. It's starting at the contact point to the cage wires, either because the membrane starts delaminating because of the mechanical stress there, or because abrasion starts from inside. The result is the same. You see small holes, and this shows the cleaned starting hole. And you see that many of the glass fibers are already broken. It's difficult to judge whether the membrane is broken first or whether the glass fabric started breaking and then the membrane was tearing. It doesn't make a difference. The outcome is the same. You will observe increased emissions. So finally, after several other approaches, the operator decided to go for P84. Along with the OEM Bold Rocky, the bags were ordered and installed. But right after startup, I received an urgent call that they would have visible dust emissions right after startup. So it was clear the emission cannot go through the bags. It's impossible to push so much dust through a P84 bag. So I've advised to check the tube sheet, the bypass dampers, and also the clean gas duct for any leakages or dust deposits. 20 hours later, there was no dust coming outside of the bag of the stack any longer. They found a dust deposit in the clean gas duct, removed it, and everything worked perfect. After 1.5 years, we've analyzed the used bag, and you see there are still orange imprints from the cage wires. There are still corroded cage wires, which created damage to the membrane bags. But within 1.5 years, none of the P84 bags shown any fatigue. And not only the corrosion of the cages, this was roughly a handful of corrosion products, which we found inside the bag. Biggest share coming from corrosion of the clean gas plenum. And even though this does create some abrasion, a needle felt has also a non-woven wear layer on the clean gas side, on the cage side. So this wear layer can be abraded without any damage to the bag and performance. And this picture shows right at the contact point to the cage wires, there's no corrosion, there's no damage at all. You see just the orange corrosion products on the bottom on the clean gas side and the permanent dust cake on the dust side. The problem in this plant is mainly the low operating temperature in compound operation, which is just around 100–120 degrees C, which easily leads to condensation and corrosion of the mild glass housing of the baghouse. The former Lafarge and now Novoco Vistas plant in Sonadi is another example. This was a hybrid baghouse, and the design in hybrid baghouses typically is a more aggressive than in a full baghouse. So the AC ratio was 1.2 meter per minute, and they observed damage mainly at the inlet, but after replacing failing bags, the damage extended to the entire baghouse. Switching to P84 solved the problems. They have no premature bag failures, or just very, very little, which do not demand for additional maintenance shutdowns. Another hybrid system at the same location, but a different OEM. A little bit lower AC ratio, but it may also be that the gas distribution across the baghouse is not evenly. So locally, you may still have positions where you exceed the limits for woven glass. The second former Lafarge and now Novoco location is Arasmeta. It's a 100% baghouse with an AC ratio slightly above 1 meter per minute. There was quite stochastically distributed bag failures, and the main reason was too much mechanical stress. And the solution, which is proven now, was P84, like in the other cases. Another LX baghouse. There are 2 lines at Heidelberg-Damow, and instead of bag failures after a few months already, and then continuing during the life, they achieve now 3–4 years bag life with P84, with just very few bags which need to be changed prematurely. And here one reference out of India, but now owned by Shree Cement Group, the Union Cement plant in Ras Al Khaimah in the Arab Emirates. This plant started from the very beginning with P84 bags. The baghouse design is relatively generous with an AC ratio well below 1 meter per minute, even at maximum gas flow. But what they have achieved is an emission constantly below 5 milligrams for a bag life of 7 or 8 years. They've changed 50% bags after 7, 50% after 8 years. And the pressure drop is only 6 to 7 millibar, which saves a lot of money. This graph shows a direct comparison in a lab scale test trick, but the material we have used was a woven glass bag and a P84 bag, which have been installed alongside each other in a baghouse. And you see that with the same cleaning set point, the pressure drop is 15% lower on an average with P84 in comparison to the woven glass. Considering that the costs for ID fan power are typically higher than the costs for the filter bags, even with high temperature filter bags, you should also have a look on your costs for ID fan power, which are just determined by the bag costs. But they contribute maybe even more to the operating costs than P84. So we did a calculation for 666 cubic meter per second. This is roughly 40,000 cubic meter per minute, equaling a baghouse in the size of 40,000 square meters, which roughly equals a 10,000 ton per day kiln. We can make this calculation also with your energy costs, your pressure drop experience, but with this difference, we could show the difference in energy costs is more than $100,000 per year, which is more than 10% of the bag costs per year. So the typical payback of P84 bags, even if a woven glass bag is performing very well for 2-3 years, is typically not more than 2-3 years. And for the rest of the life of P84 bags, you save more money and you can sleep well because you know that the bags will perform well. So in summary, due to the higher performance of P84, you can keep your baghouse smaller. You can also keep your ID fan at a typical regular size, and you don't need to increase it because of a high pressure drop, which means low, along with a reduction of the total cost of operation. Thank you for your attention.
Yes, thank you so much, Dr. Santorsola and Dr. Rathwallner. That was some great insight, and I'm sure these are solutions that would benefit the cement industry in India, and it is definitely something that they would want to know more about, which we would also look a little more into detail in our discussions going forward today. For all our attendees, please do not forget to check for the handout drop box in the right side panel. There are some valuable materials for you out there in addition to all the information that has been shared in the presentation. So the cement manufacturing process in India generates highest level of pollution next only to thermal power generating plants. The industry has been growing conscious in its approach towards emission reduction. Undoubtedly, the current scenario of pollution levels that cement manufacturing contributes to makes it critical for manufacturers to consider adopting technological advancements, just as what we just spoke about, towards reduction of emissions in cement plants. So to set the context to take this discussion forward, my question to Mr. K. N. Rao, if you could tell us about the evolution and current regulation of particulate emission standards in India, and what challenges are cement companies facing in meeting the same?
Thank you for all the co-panelists. Excellent presentation by Georg and Mr. Stefano. When we think about the environment regulations in the country, I think we can make it as two parts, that before 1984 and after 1984. This is the Bhopal gas tragedy, which took place in India in 1984, and then most of the Indian emission regulations have been made stringent post the event. So in the early stages of cement industry, that the vertical roller mills were not there, and the cement kilns were only dry process kilns, and we were getting the gases in a constant temperature into the ESPs, and those are time where people were using electrostatic precipitators and using the having a constant temperature, we're able to maintain a constant performance. And subsequently, after the introduction of VRMs, vertical roller mills, then there is a fluctuation temperatures in the kiln gas streams, and in the process that the cement kilns were not able to operate consistent low emissions with the using ESPs. And many cement plants post 1980, after the liberalization of cement industry, delicensing, many cement plants what has been installed start producing almost double the capacity. And such a situation that the equipments which have been installed in the plants were not meeting the regulations, because it has to handle the higher the flow quantity, and also it is also having a problem related to the equipment itself, because when especially in the electrostatic precipitator, we have a carbon monoxide comes from the combustion process, which leads to tripping of the electrostatic precipitator to prevent the explosion of the ESP. So that is the where most of the industry actually start looking into that, how to ultimately retrofit my existing equipment to operate at the higher capacity, and at the same time I should not have a trip of the control equipment, which is creating huge dust emissions from the cement plants. So that's the area where first time Indian cement industry also thought about using bag houses. I think prior to that we have electrostatic precipitators, and the government regulations were 150 milligrams per nm cube was the emission standard. And over a period of time, the emission regulations have been further lowered to 50 milligrams per nm cube. And recently in 2015, the government has come down to 30 milligrams per nm cube. With the current emission standards, and also the government has introduced not only the dust, government has also introduced standards for the dioxin, furan, and also heavy metals, volatile organic compounds. All these have been actually brought into the emission regulation, because most of the cement kilns were using alternative fuels like municipal solid waste, hazardous waste, industrial waste. All these and biomass has been fed into the kiln instead of a clove. So with the changed conditions of the fuel and also increased capacity at 30 milligrams emission, that is the currently for the cement kiln, there is no other choice that you need to actually change to bag houses. Now, some companies who had ESPs and they were actually trying to change into bag houses. Some people have the ESP is very large enough, they could convert into hybrid filter. And some people ultimately they installed the whole ESP, they converted into bag filter. And if the ESP is in not healthy condition, people have installed a greenfield new bag house for the cement kiln. Simultaneously, the regulations, when the new regulations came, now this new membrane, or whether it's a PAD4 or a membrane filtration, which is helping the not only catching the dust and also catching the heavy metals, dioxins and furans, and able to help the industry to comply to the emission regulations. But in addition to this compliance, the government also came out with the online reporting. Earlier, whenever there is a upset conditions like startup and upset, then there is a chance that the emissions are going up. Now in the present situation, the government is asking all the stacks to report live to the regulator. And now the problems for the challenges for the cement industry is that the availability of the bag house and the availability of the measuring instrument, which is reporting to the pollution control board. If there is a discontinuation of the communication, which leads to non-compliance, if there is any failure of the filter bag, which leads to high emissions, also gets a notice to close the plant. So in the current situation, it's very important for the cement industry to adopt a filter fabric, which is actually have more reliable and doesn't fail, and also give a longer life and doesn't have surprises in the operation of the bag house. In addition to that, now the energy cost has become very important for the cement industry, and the bag house, which is already has a higher pressure drop compared to the ESP, now we want a fabric which is having a low pressure drop and also having a reliability in terms of emission and have a longer life. I think that's one of the area that my personal experience, having tried out many glass bag houses for the different plants of ACC, that I experienced frequent failure of the glass bags. And in many cases, I tried out with the PAD4, and I was very lucky that I didn't have complaints from the pollution control board, because the plant is operating constantly with the constant emissions much below. Like the regulation talks about 30 milligrams per nm cube now, and we are able to operate the plant less than 10 milligrams per nm cube. That actually given the comfort that, okay, the PAD4 is an expensive material, but if you see the life cycle cost, that in terms of the life and the power savings and the amount of shutdown and the maintenance issues which are associated, we found that at the life cycle cost wise, I found that it's very it is ultimately at a comparable or a better performance with respect to on the life cycle cost basis. And now it is for the cement kiln, but there are lots of other pollution control equipment in the cement plant, like CPP, captive power plant, and also the other cement mill, coal mill, and many other applications, we found that the fabrics are having a very important role in terms of the plant's energy consumption, and also maintain very low emissions and not to have any regulatory problems with the government and also with the community, because it is not only the communities also like to see that their atmosphere is not actually getting affected, because see the case of Delhi, where the PM 2.5 and PM 10 particles are almost 10 times of the limit. So it is very important that around the cement plant, that how we maintain the emissions well within the limit, and to ensure the health of the people. That is something which is extremely important. So I think the regulations which have changed now today, I can say that the Indian regulations are all on par with European regulations, whether it is in Germany or Western Switzerland or in Sweden or Norway. Indian regulations are comparable. I am very sure that the Indian cement industry has took the challenge and ultimately upgraded the equipment, and there's a lot of work to be done. I'm very sure that India is on the right path.
Yes, that's great to know that our regulations have reached a point where change is a given, and we can see that change coming in with time. Also, like you rightly mentioned, the need to adopt a filter fabric with low which ensures a low pressure drop and reliability is important. And also the fact that you mentioned that don't just look at the expenditure, but also the life cycle cost. I think that is also a very important point that should be noted. From there, I would also move on to Mr. Shekhar Joshi. That how has the technology evolved for pollution control equipment, and in the present day, which technologies and equipment are in use to control emissions?
Actually, for the cement industry, ESP or kiln is one of the largest polluter. So till 1985, ESPs were predominantly used for kiln application. But later on, after 1985, people started or the users started using the reverse air baghouses, which are giving emission comfortably below 50 milligram per NMQ. But afterwards, there were strict restrictions placed by the government, and in between the period from 1985 to 2010, I think reverse air baghouses were predominantly used. But later on, from 2010, people started using the pulse jet bag filters for this particular application. People started using with either glass bags with membrane or with PAT4. But as you are aware, as explained by Mr. Stefan Santorsola, there were many failures for the glass bags, and later on the user started using PAT4 in the pulse jet bag filters. So right now, most of the people now nobody uses ESPs or even reverse air baghouses to that extent. Mostly the manufacturers go with PAT4 with pulse jet bag filter.
So that is where we stand in terms of the current scenario in terms of adoption and what most manufacturers are going in for. Also, Mr. Rao, if you could tell me that in the present day, where does the industry stand in terms of meeting the requirement of the Pollution Control Board?
I think if we look into the particulate emissions within the cement plant, we have a captive power plant, and also we have a in the cement plant. Many cement plants in India have a captive power plant, which are coal-fired power plants, and some are coal-fired biomass combination-fired plants. And they also have emission regulations, and those also have been tightened. And many plants who are still operating with the ESPs, and they have a problem. I think there is a lot of work to be done on the captive power plants which are there in the cement plants. And now recently, I think during my tenure in ACC in the last 2 years, I converted many captive power plant ESPs to hybrid filters, hybrid pulse jet filters, so that as the ESPs are large, and we are able to replace a couple of fields with the baghouses. And after that, we brought down the emissions from 150 to 200 milligrams to the levels of less than 10 milligrams and less than 20 milligrams. Even the regulation is called for 50 milligrams. We are far below that. It's especially the operating the ESPs, like what happened in the cement kilns. It is the same challenge that in the captive power plants, we use a high ash coals of India and having a very high resistivity, and those ESPs were not performing well, and in the process that when we shifted to BAGOs, and we could ultimately address the emissions. Similarly, today the big challenge is about non-emission non-compliance, especially that to the plants which are using pulse-jet back filters with glass bags, and there is a huge amount of back failures, and the regulators are giving the show cause notices and penalties, and something is required now. The industry need to look into the filters which are actually not able to maintain consistently from 24/7 365 days of emissions less than 30 milligrams. These are really challenge, and a lot of companies are actually shifting to the fabrics, moving into the materials which are more reliable and having a lower power consumption. And 8 to 9 years life. Say for example, if I use a set of 1 P84 bags which is running for 9 years, if I had to get the same time, I have to replace the glass bags 3 times in the lifetime, equivalent time, and I have to replace also the cages. So the big challenge is there that availability and the type of shutdown which is required and the replacement cost is very, very, very huge. And also as the life of the bag goes down, then the pressure drop also goes on year, it keep on increasing. So that is another big challenge, especially when we use the glass bags with membrane. Like, this is my operating experience of many plants of Lafarge Holcim in India. And the new regulations which came about, the sulfur dioxide regulations on SOx, especially India using the sulfur dioxide coming from the coal burning in the captive power plants, and also some plants who have been using earlier petcoke. Now the petcoke is having a very high sulfur. Now the government has banned usage of petcoke in captive power plants, and now people are using only the coal, even in that case also. And it has become a challenge in terms of maintaining the SOx levels less than 600 milligrams per RM3. And similarly, the NOx coming from the boilers also, to maintain the limits of 300 to 600 has become a challenge. And a lot of companies have gone for SNCR systems and SCR systems to control the NOx. Similarly, the clinker coolers in cement kilns also had ESPs, and people have not retrofitted the ESPs of clinker coolers. There also there is a challenge of maintaining the emissions less than 30 milligrams. Many cement plants went for waste heat recovery power plants, and in the process that they could bring down the temperature. In the process that on the clinker cooler also, people start using the BAGOS technology instead of using the ESP technology, and many of people are actually retrofitting the cooler ESPs and converting into a fabric filter solution. So this is one of the biggest challenge for the cement. I think now that today, if somebody is putting up a new plant, they will not be consuming any ESP for a cement plant. They will be using only the pulse-jet back filters. They will not be using reverse air bagoses also. Now it is pulse-jet bagos, and ultimately within the pulse-jet bagos, you have a couple of options of material are available. And what we require to look at is the bags which last for 7 to 8 years as a life. That is something which should be the industry need to adopt, which ultimately eliminates the type of reliability of the plant operations.
Yeah, so we are saying that the bag life that we should have is 7 to 8 years at least. And definitely, I think some very interesting points in terms of the challenges that the industry is facing. And I think through this discussion, what we're also trying to do today is give the solution, to these challenges in a way. So yes, while I do have questions for my panelists, I also have questions for the attendees. So are you looking for long-lasting and reliable filter media for the bag house in your cement plant? You're going to respond to this by doing it through my live poll. I'm just going to launch a poll for you. So yes, like you can see the poll, all our attendees tell us that are you looking for long-lasting, reliable filter media for the bag house in your cement plant? Yes, no, maybe. We would like to see, what kind of responses come in, and then I would move on to Dr. Rathwallner to just discuss this a little more. Oh, right now we're seeing that majority is going with yes, followed by a small percentage that says maybe. So we have like 70% plus that says yes, 20%, 30 says maybe. There's a 10% which says unknown. I'm closing this poll. Here's the result for all of us to see. 64% yes, 27% maybe, 9% unknown. So from there, Dr. Rathwallner, how can companies improve the bag house performance like selecting the right filter media, of course. We also know that P84 comes with a USP of highest filtration efficiency. So how does all this become important, and how can companies improve this baghouse performance?
Like mentioned in the introduction by Stefano already, a membrane on woven glass is working ideally under ideal conditions. Under lab scale conditions, you see almost zero emissions and it works perfectly. But under real conditions, it's different. And it doesn't even start with the condition of the baghouse. It starts with well-trained personnel to install the bags properly. You can make a lot of mistakes and damage the bags already during installation. This was the reason for our big success in China, because in China, the conversion from ESPs to baghouses has taken place in a much shorter time period than in India. I would estimate some 60–70% have been converted within 2 or 3 years. And just before this happened in a big scale, I recognized that woven glass is not working perfectly in China for various reasons. It's either the material quality, also within woven glass, there's a wide range. It could be problems during installations. There are also issues like dimensional fit. The dimensional fit of woven glass to the cage is much more sensitive. If it's too much or not enough, you will create damage to the bags. With a needle felt, you have a wider range of variations which you can accept. Needle felts have been used as a workwear, not produced by needling, but also by felting. So a similar material was used rather than woven material, because for workwear it was important to be robust and abrasion resistant. So with P84, you're on the safe side, also the new side of bags, because in China it simply turned out, if you don't have a trained supervisor and some skilled personnel, you will create problems sooner or later. And especially if your baghouse is a few years old, you see many plants working with woven glass for 5 years without problems, new plants. Then you get corrosion. So the second set of bags is maybe just lasting half of that. And then it's getting worse and worse, and failures start even after a few months. This is simply because conditions become less and less suitable for woven glass.
Right. So I think the topic of woven glass is something that, you know, I would elaborate with almost each and every panelist when we go from here. And with that, I will take my second question to the attendees, that how consistent is the performance and reliability of bag filters that you are using at present? Is it good? Does it need improvement? Or is it not good? So I'm launching my next poll. So yes, tell us how consistent is the performance and reliability of the bag filters you're using at present. And from there, you know, just taking forward the point that Dr. Rathwallner mentioned about the woven glass, I would go to Dr. Santorsola, that, you know, we've seen that in India, woven glass is commonly used. So maybe once we see the results, we'll go a little bit into how the P84 polyamide fibers perform better than the woven glass. So I'm seeing right now with the results, we have 64%, and it's going up, which says needs improvement. Around 20% says good, 12% not good. I'm collecting the responses, closing the poll, and you're sharing the result. So yes, Dr. Santorsola, like we can see, we have 61% that says needs improvement. There's followed by 28% that says good, and there is 11% that says not good. So how do P84 polyamide fibers perform better than the woven glass, and to what extent do these reduce risk for deteriorating performance and add to the life of the cement bag?
Thank you, Shriyal. Very nice question, and also very self-explanatory result of this second poll. I mean, we have more than 60% of users in cement industry which declare that their filter media could perform better than what actually is the performance. So this tells us a little bit everything. As Georg also mentioned before, as long as a PTFE membrane on a woven glass operates under very precise and strict conditions, these media can perform perfectly as long as it lasts the required number of years. I mean, as long as it lasts for 4 to 5 years, nobody should change it. But this is not the case, and the picture given by the second poll is clear, that the PTFE membrane indeed is more fragile and subject to premature failure. Call it abrasion from the flow gas, call it mechanical damage due to the impact of the woven glass on the cage during the pulses, etc., or even during the handling of the bags, even before installation. So the question, I believe, is the following. Do we know exactly how much this poor performance of glass membrane is impacting on our balance sheet? And sometimes I believe the response is not completely, because what people tend to do is to focus on the price difference between a PET4 filter bag and a woven glass filter bag, which is a very easy and understandable approach. I mean, you look at these bags and you see, oh, if I buy PET4 bags, that would cost me, I don't know, 30%, 35% more. I'm just giving out, I mean, something like, and why should I do that? But people tend to forget the hidden costs of ownership, which are to be ascribed to the unexpected maintenance interventions, which can occur on a weekly or monthly basis, depending on how many times you have to replace woven glass bags as soon as your emission exceeds the limits by the government. And this includes also the fact that during the intervention, you may have to shut down, at least partially, or to downgrade your production, which is triggering another exorbitant cost in production. I mean, you're producing less clinker. And if you're producing less clinker, you earn less money by selling this into the market. So we may go on for a while just mentioning these elements, but it's clear that when deciding which type of filter media you would like to have operating in your plant, everybody should consider how much money I want to earn at the end of the day or at the end of the month. So a 360 degrees approach would be preferable. And PET4 is in that sense a very, very solid answer to all these questions. I mean, it's not just that needle felt intrinsically stronger from a mechanical point of view, but thanks to this, as explained before, unique multi-level cross-section, it can really perform in a way that no other fiber can in terms of filtration efficiency, retaining the dust from penetrating the felt, and with a shoot of other positive effects like pressure drop, regular and constant through many years, and much longer bag's life. And therefore, also lower cost of ownership, including the suction fan, which is the main energetic cost in a cement plant in terms of flue gas treatment. So I believe this answers a little bit the question.
Yeah, also, if you could tell me a little bit, like you mentioned, that it's also important to consider the kind of maintenance cost also that goes in, depending on the quality that is being used. So what is the kind of maintenance that the P84 bags call for? What is the maintenance requirement?
Oh, actually, there's no maintenance required. So I mean that once the bags are correctly stored in a warehouse, as long as you don't expose them to a flood, they can stay in your warehouse for years, and you can take them out of the box and install them right away, and they will perform same way as they would have been produced the day before. P84 bags can be, I would say, almost dragged on the floor before installation, because we know how these operations occur on top of a bag house. There is a lot of carton boxes, there is a lot of cages dismantled, pulled out of the plenum, and people running right and left. Can you imagine how many times people would just walk on a new bag before this is installed correctly? And this doesn't make anything. That makes nothing to a PET4 bag. On the contrary, it would already destroy the membrane in several points, the membrane of a woven glass. And that's already a big difference. Without mentioning what already George said before, that during the installation of a woven glass PTFE bag, you need to have special protective collars to avoid the abrasion with a tube sheet hole, which is typically sharp and abrasive. And so, yeah, I would say the maintenance required by a PET4 bag is the one that you spend when you decide to remove them after many years of operation.
And I think another interesting point that you did point out to was also, to look back at not just the cost you're putting into like investing in these, but also the impact of a lower performance bag on the balance sheet. I think that is important, and that is a great area where we can save on cost. Uh, Moving to Mr. Joshi, that woven glass bags, like we are talking about, are still the most common filter media in kiln bag houses in India. Under which conditions would you recommend P84 polyamide fiber?
Actually, earlier glass bags were used because the bags were cheaper. Secondly, there was good experience of glass bags in the reverse airbag house. So that was a commonly used material in reverse airbag house. But reverse airbag house takes a lot of space, and it requires a lot of weight for erection as well as fabrication. So people started using pulse-jet bag house. But while using pulse-jet bag house and a glass as a combination was not a good one, because the people were not getting very good bag life. Secondly, the P84 is specifically useful if you are operating your bag house at high air to cloth ratio, and if the volume is increased, or secondly, if the dust load is very high, if you are not installing the cyclones after the raw mill, and if you are taking the gases directly from the mill to the bag house, the dust load is very high in the bag house, and in that case P84 is ideal, because there are various instances of using P84 bags even up to 700 grams per meter cube dust load. So these are the basically conditions where you can use P84 comfortably. You cannot use glass bags for high dust loads.
I would also extend, this question to Mr. Rao, like Mr. Joshi mentioned, that woven glass is used because it is cheaper. But, keeping in mind a lower life cycle of the product and the need for companies to guard themselves against any sanctions or penalties that they may get from the government, will it not be more prudent for cement manufacturers in India to consider a higher grade material, like we are speaking about the P84 polyamide fiber?
So when I was looking into the selecting the right kind of fabric for because Lafarge Holcim operates around 32 plants in India, and I looked into that, what is the cost economics, then I found that if we stop the kiln for one day of a 10,000 tons plant, the EBITDA impact is around 1 crore from one plant one day. So this is the 10,000 tons producing most of the cement companies are operating at 25% EBITDA level. And if we look at the amount of profit has gone for stopping the plant for one day, because of stopping the plant can happen for multiple reasons, that the regulator has given the notice to shut down the plant because you are exceeded the emissions and you got so many alerts, and in the process you stop. Then to replace, first of all, any bag failure in a large bag filter, to diagnose which bag has failed in which location, that itself it takes long time. Later the equipment has to get cooled down, and the bag has to be identified and then replaced, and this is going to be a very huge cumbersome exercise. And we found that the huge financial loss are happening of identifying the failed bag and also replacing it, apart from the power consumption and other things. And then anytime equipment cools down and once again you restart, then large amount of energy is put into the kiln to once again to the normal temperature. So a lot of fuel is being wasted and a lot of manpower cost, and EBITDA, 10,000 tons of production has lost, and which is having effectively 1,000 rupees per ton, which leads to around 1 crore per day is the EBITDA loss. So when I see the cost difference, so it doesn't. Now I'm not saying that this is the problem for Indian applications, is that the Indian cement industry uses the limestone which are high silica content. So the membrane is a very thin surface, the thickness surface, which can get abraded. One is either bag is touching to another bag, the membrane gets worn out. Similarly, a bag is touching the metallic wall, it also goes, and the dust is abrading the material. And second thing, a third one is that if the gas is entering into the filter, if the gas is not uniformly distributed, that creates a turbulence inside the filter. Due to the turbulence, the membrane also gets eroded. So the problems are multiple location, and also both of them mentioned that the quality of the cage. And since the bags are very long in nature, and the quality of the cage and the fitment is very, very important. And in view of this, what I found is that in spite of doing many trials, that RABH, reverse air bag house, glass bag is good. There is no problem. But when you think about pulsate, the glass is not performing with membrane or without membrane. It's not able to deliver the performance because of the problems what I mentioned about the nature of the dust of the limestone dust in India, and also having the huge dust load. So felt materials, non-membrane material is actually more suitable. There are two options. One is the Teflon, and the other one is the PAD4. These are the two materials which are suitable. And these both the materials have the desired properties. Even I see the Evonik, some of their plant that ultimately whatever they recommend, that many plants we have tried out using PTFE screen, Teflon screen with PAD4 as a filtration material, and to get a much more life. So basically PAD4 and PTFE screen is something which found to be having a very good performance both in terms of acidic environment and alkaline environment. Of late, cement plants are using huge amount of waste. I think 5 years before, India using hardly 2 to 3% of alternative fuel. Now, today, many plants are operating at 20% alternative fuels. Municipal solid waste is going into the kilns. When you are getting a lot of chlorine and fluorine and many other the materials are coming into the kiln, which you don't have any chemistry known to, but all these gases are actually having impact. So it's very important that the fabric which is actually able to take care of the adverse conditions, like it is almost like you can say cement kiln in future going to be a municipal incinerator. Now you're going to fire the like a incinerator, and then you all gases it ultimately fabric should be able to withstand. So this is not the condition 5 years before when we are not using any alternative fuel. So that's very important, that where you are not very sure what you're going to fire next month in the kiln. I'm going to do fire of biomass, I'm going to do petcoke or coal, or I use lignite, or I use municipal solid waste or industrial waste, or what I do. So when everything is uncertain, then your fabric, what you're using, you should be capable of handling all these materials and able to maintain a constant emission. So that is the future for the filtration, because we don't have any control on the type of fuels we are going to use in the cement kilns. And we are talking about installing a bag which is going to last for 8 to 9 years. In the 8 to 9 years, there is a big change in terms of the type of fuels we are going to use in the cement kilns. In that particular context, now we have to see the life cycle cost, and in the process that we will be able to justify. And now there could be incremental cost, but once the volume goes up for the even for PAD4, most probably the prices will come down because the offtake has to increase. So like we have seen in every area that wherever the offtake has increased, then there is a scale of operations in which the volume of the filter fabric consumption has gone up. Most probably the input cost also will come down. So there is a necessity, what I see from 1 year from now, that at least the one is that to make the people adopt the latest technology, and in the process that the volumes goes up and then price comes down, and people able to use a reliable material, and for at least for a life of at least 8 to 10 years. I personally have seen, I was in Slovakia, I think in way back in 2005. I went to a Lafarge plant. I found that when I visited the plant, it was already bags have completed 8 years of life. I've been chasing for the bags whether it can last for more than 4 years on the glass, but I've not been successful. That I not come across any glass bag on pulsate. I'm saying reverse air glass bags have given 6 years life, but on the pulsate I could not get any fabric which has completed 4 years life. So I personally feel that.
Yes, and I'm still struck by the point that you made on the, EBITDA loss when we are saying 1 crore per day, in a situation. That's a big number. And I think this is very good information that is going out in this panel discussion, that it is important to know these losses that can incur in the long term and make the right decisions when it comes to material selection today. I'll quickly go to our next poll to the attendees. We did mention, energy savings and the high cost of energy being a challenge. So is energy saving in baghouse a priority for your organization? This is going to be a quick one I bring to you. Launching this poll, the options are yes, no, or maybe. Is energy saving in baghouse a priority for your organization? And I would request Dr. Santorsola or Dr. Rathwallner, one of you could take this up to comment on the poll result and also speak on, how the P84 polyamide fibers could help in energy saving. It's hands down, and it almost went to like 100% yes. And now Okay, now we're seeing more no's and maybe. I'm closing the poll with that, and I'm launching the result. Conclude this session as well very soon. So we are seeing it's 84% says yes, of course, 11% no, and 5% maybe. So who would like to, take this to the poll?
Please, a few minutes remaining. We may even share, George and I, but I would say one thing. The picture is very clear. There's a very, very dominant majority of people understanding and accepting that the energy saving is an important target for the operation. Let's not forget, the ID-fan energy consumption is not the only one cost. When things are not doing right, as we mentioned before, there is another array of hidden costs, which include the unexpected maintenance and the loss of production. These are it can be by far more painful than the energy cost saving itself. So let's talk, hopefully, of a total cost of ownership when we consider the selection of a filter media. Then I would like to hand over to George, because indeed we have the possibility to analyze data from each and every plant and come to specific suggestions on ID cost.
Almost looks like there would have been many technicians in the webinar, because we always get positive feedback. Yes, of course, we understand we need more reliable material, otherwise it's their pain. They want to save energy. The problem is you need a holistic approach. It was not a cement plant, but it was a boiler plant where we informed the maintenance engineer responsible for the baghouse. You could save that much ID fan power if you invest in better bag material. And he said, I would be an idiot. That's not on my account. I'm only responsible for the bags. The ID fan power is on another account. So we realized you need to go one level higher in management so that at the top, people can balance. They understand an investment in one segment brings savings in another segment. You need to have the entire picture. This is often a hurdle to really convince the top management that an investment rate will pay back relatively quick. In case of a shutdown, as Mr. Rao mentioned, that's what we have confirmed in many calculations. If you have a 10 days maintenance shutdown, which is not very long if you have to find damaged bags and replace them, costs more or less as much as an entire set of high quality bags. So with the first unplanned shutdown, if you could sell more clinker, you have already spent more money than you would have spent with the most expensive bag material available.
Thank you for that. And now I'm going to take the last question to just conclude this entire discussion and summarize it. That considering the present scenario in India, I think we've had a lot of insights that have come into the forefront in this discussion. If each of the panelists have to share their expectation 1 year down the line, what improvements do you expect in the pollution control scenario in the cement industry? We'll take this very brief, very short from each panelist. I would begin with Mr. Joshi.
In fact, right now, people are using glass bags as well as P84 and moving to the pearl jet bag filters. I think over a period, after seeing the total cost analysis, they will move to P84 rather than going to glass bags. This is my thinking.
Okay, Dr. Rathwallner?
I believe it will continue, maybe speed up a little bit if there comes more pressure if you violate emission standards. But it will take another few more years until all the exhaust gas cleaning equipment in the cement industry is at a really high level to consistently ensure low emissions without unnecessary maintenance shutdowns.
Dr. Santorsola, your views here?
Thank you. I believe the Indian regulation frame is very clear, and you are already at the same level of Europe. What I expect to be improved in the near future is the mindset of people in approaching considerations before they do some expenditure for new filter bags.
And Mr. Rao, the concluding statement from you.
Yeah,
to this.
I see in 1 year from now, I think currently we are in COVID pandemic, and the regulators are not seriously imposing penalties because they're also operating from the home. And 1 year from now, I visualize that there will be stringent enforcement of penalties on the companies if there is any emission exceedance is there. Now, at that particular scenario, that the companies has to see, one major shift which is required is that look at the life cycle approach and don't look at the initial cost. I think this is something which is a message. I'm very sure that many companies will adopt a life cycle approach. My request to Evonik is try to see that you come out longer guarantees. Like today, what people have experienced is about a longer life. But when you offer the products, and if you're able to offer a longer life guarantee, and people are able to account that in the life cycle calculation. If you say that I'm going to give a 4-year life and the glass guy is also giving a 4 years life, they will not be able to show the differentiation in the cost in their life cycle cost. It's very important that you are able to give a longer warranties for the bag life, and also able to give a aggressive realistic pressure drop guarantees, which ultimately will reflect in the life cycle comparison. And also with the increased volume of the sales, most probably you will be able to bring down the price of these bags so that it is affordable to the many companies. So that's something. But I'm saying that the industry is shifted from ESP to bagos, and bagos with glass bags, and if people are learning by doing something, that they have actually installed a bagos and they've gone with the fiberglass bags with membrane. Now what I visualize is that the market is going to go up next year. The cement demand is going to go up from the existing filter without changing anything. If you want to increase the production by 20% or 10% to 20%, you can do achieving this by changing the bag, where you're going to get additional manufacturing capacity for the cement plant. So this is something is my view, but I say that please adopt a life cycle approach. All the participants, I'm requesting that don't look at the initial cost, calculate the life cycle cost of the bags. So that's something which actually gives you clearly open up the in the technical comparison of the products.
So we've almost come to the end of our time, but I see some questions that have come in from the attendees, and I would like to take at least 1 or 2 questions before we close this. We'll see how we can just do justice to responding to these very quickly. So we have a question that apart from cement application, can we recommend P84 in boiler and waste to energy application as well?
Yes, P84 is quite commonly used in Europe in waste to energy plants, either pure P84 if the temperature range and the chemical environment allows, or if temperatures are going too high, typically a blend of PTFE with P84. Both on PTFE trim, since the mechanical reinforcement for that PTFE is the cheapest and best suitable solution. There was a lot of PTFE bags with PTFE membrane in Europe in waste to energy industry initially, but a good share has switched to P84 blends or pure P84 because of the higher reliability in comparison to a membrane product, even if it's laminated onto a non-woven base material, and because it allows consistently low emissions throughout the life. Waste to energy industry is quite sensitive in Europe. Some of them even oblige themselves to comply with just 3 milligram emissions. So it's really delicate. And other industries, in coal-fired boilers, there are some smaller boilers in India, which are using alternately either rice husk when available, or part of the year Indian coal. From that experience, we know with Indian coal, there's almost no risk for chemical damage to P84. This works well. There's no excessive acid. P84 is not suitable for high sulfur coals without neutralization, but all systems with dry or semi-dry flue gas devaporization are suitable for P84 or P84 composites, also PPS P84 composites at lower temperatures.
Just a small adding.
Yes.
If you allow me, back to waste to energy or incineration plants, depending which is more fashionable to call. But P84, very important advantage there is recognized in allowing the creation of a very thick reactors bed on the bags. Same as we discussed before, the permanent as cake in a waste to energy plant means that the sorbent can stay longer on the bags and allow for a secondary sorption which occurs on the bag, thus making the operator of the plant save big money in sorbent utilization. So that's a very systemic advantage of P84 towards any membrane which we know cannot hold a significant cake of reagent.
And I could tell the
yes.
attendees that, you know, for anything more that you would want to know on P84 and the hot gas filtration, I have displayed the contact on the screen. So that would give you the answer to most questions. And I'll take a last question, that what are the chances of the membrane getting damaged during transportation?
Yeah, the problem with the membrane is that when once the bag is stitched and the glass bags tend to remember the fold, and so they tend to get damaged during the transit or in the installation or handling. This is something has been seen in many plants, that membrane do get damaged, but if it need to be the how you handle a membrane bag is almost need to be extremely careful. How you handle definitely like a electronic product, how you handle safely, that is the level of care is to be taken. How you store it, how you handle it, how you transport it, and how you open it, all that requires the skill levels are required for handling the bag. Otherwise there will be tears will have, some of the locations the membrane get teared. This we have seen in the testing also.
Thank you. Thank you so much. And thank you all the attendees for joining us today. A special thank you to all the panelists for all your time, for joining me in for this discussion. I hope it's been as insightful for everybody as much as it's been for me. And I would take this opportunity to thank you all, Dr. Stefano, Santorsola, Dr. Georg Rathwallner, Mr. K. N. Rao, Mr. Shekhar Joshi. Thank you for joining me in. I'm going to continue, bringing to the industry such webinars so that we could move towards more solution-oriented and, making a change in the industry for the better. So till then, continue tracking us. Stay tuned with us. Take care till I meet you all next. Stay safe, and we will see you all soon with our next webinar session. Have a good day, everybody, and have a great weekend. Thank you so much.
Thank you. Thank you. Thank you very much.
Thank you.
Thank you.
Bye, everybody.
Thank you.
Thank you for
Bye.
attending.
Thank you.